about circles. Something you know quite a bit about already, I'm sure, but we're going to add a little bit of detail to this whole thing. So if you did follow along in the previous video and made your circle notebook, I'm going to go through for the first page and then the second page what notes you should add. And I'll have diagrams and everything. Okay? Remember, you can rewind this if you need to see stuff again, pause it, however you see fit. So the first thing we're going to talk about is what the definition of a circle is. So simply put, a circle, spelled correctly, is the set of all points that are equidistant from a point called the center of the circle. So what this means in practical terms is the circle itself, as in this black outline, is the actual circle, and it's made up from a series of points. So if you think about it, 1 point, 2 point, 3 point, and so on, they're all the same distance from the center, which is right around here. So if you took and drew all those points out, you'd get a circle. Now when we're naming circles, typically what we'll do is we'll do a little symbol that looks like a circle, kind of like when we do with a triangle, right? And then we'll do whatever the letter is that represents the center of the circle. So in this case we'd say circle P, and that would mean P is the center of that circle. Okay? The next thing we need to talk about circles are some of the characteristics, and one of those is something I know you've heard of, which is the radius. And that is a segment that connects the circle to the center. So if you're looking at that, that would mean you'd be looking at a segment just like this, and let's say that's the center right there. That would be an example of a radius. And that's how we define a circle. A circle has a certain radius, so that would mean that the radius, no matter what, whenever we draw that from the center to any point on the circle, because the circle is that set of points, would be the radius. And these would all have the same length. It does mean that the radius of a given circle is going to be congruent to the radius of the same circle no matter what. Now, a new term that you are going to want to pay attention to is something called a chord. So a chord, kind of like the musical chord, that's how it's spelled, is a segment that connects 2 points on a circle. So what this means is a chord would be something that looks akin or similar to this. Here's a point on the circle. Remember, the circle itself is a set of points, right? Don't forget that there is still a center of the circle. Let's say it's here, right? And we'll call this circle P, right? It means a chord could be any number of segments. So that thing there is a chord, and using our regular conventions, it means we'd say, okay, maybe that's the point A and that's the point B, so we'd say that segment AB is a chord of the circle. Anything, it doesn't matter, there's no restriction to length or anything like that. Anything we do draw in, so like this would be an example of a chord. Let's go with purple. Here'd be another example of a chord. And these chords don't have to be related in any special way. It is possible, however, to draw a chord through the center of a circle, but if we do that, it gets a special name, which you're going to have to wait to the next page to find out about. Too late, we're there. That special thing is called another thing I'm sure you've heard of, a diameter, which is a chord that passes through the center of the circle. So what that means is a diameter must pass through the center of the circle, meaning we have to define where the center is. Let's call this circle Q for argument's sake, right? That would mean then the chord would have to, I'll go with that color. That means the chord would have to pass through the center. So is a diameter a chord? Yes. So that means that all diameters are chords. Does it necessarily mean that if you're looking at a chord, which would look something like this, is a chord necessarily a diameter? No. So this works only one way. In order to be a diameter, it must be a chord, but in order to be a chord, it doesn't have to be a diameter. Now, there is a special relationship between the diameter and the radius, which you probably have already heard about, and that is the fact that if we're looking at this, which is a radius, versus this, which is a diameter, right? There's the diameter, and here's our radius. The radius of the circle is how we define the circle. We say a radius of certain dimensions, right? The radius is, I'm sorry, let's do it this way. The diameter is equal to 2 times the radius. Once again, this is probably something you have heard before, so hopefully that's just review. So on page 1, what you should do is, oh wait, I'm sorry, I need to add a couple more things here. There are certain things about radii and chords. So if you are looking at a circle, it is certainly possible to draw in a chord, and it is possible in certain cases, and this is where it gets particularly interesting, if we were to draw in this chord, and let's say we had another point that represented the center, let's say that this is circle, I don't know, circle T, right? So if this is circle T, and there's a chord in circle T, if we were to draw in a radius from the, obviously the center, but then also to the each end of that chord, then we get a special type of triangle, which you probably recognize, and that would be an isosceles triangle. So if we're looking at that, so you see an isosceles triangle because these radii, the radius, plural is radii, are going to be the same. Then if we draw in another radius, if we draw in another radius just like that, such that it's an altitude of that, then what happens is, and just like when we drew in altitudes before, that has a special relationship right there. What it does is it makes not one, but 2 right triangles. Right now I've got commentary going on in the background from my lovely family. But in any event, you can see, similar to what we did with the law of sines and law of cosines, we created a couple of right triangles. Now what this also means is, if you think about this carefully, is that this side is congruent to itself, and it would mean that this is 90 degrees, this is 90 degrees, this is an isosceles triangle, these both are, which means that this angle here and this angle here have to be the same. Now I think you'd agree then what we've got going on here is not 1 but 2 congruent triangles. That means, and this is where the big guns come in, that this is congruent to this. Now, big deal you say. Well, here's the deal. If you are looking at, and this is the consequence of this, if you are looking at a circle, not a square, a circle, let's get that out of there. If you're looking at a circle and you were to draw in a chord, and then you were to draw in a radius that is perpendicular to that chord, so let's say we knew that that was perpendicular, right? So know that that's perpendicular. Either they tell us or we've constructed it so it does. What that means is that special relationship between the radius and the chord, as long as the radius is perpendicular to the chord, is that it bisects, that is, cuts that into 2 congruent pieces. So if we were to say label this, so let's say that this is circle O. Now circle O is an oddly enough very popular name for a circle. Let's say that was a point A, get back here, A, B, and C. Then that would mean these intersect at point D, let's call it, right? There's D, and then here's C. This means that we can safely say that because this radius is perpendicular to this chord, it bisects it, which means that CD, remember how we name segments, little line on top, is congruent, same size and same shape, right, to BD. Now that can come in very handy. Now as another consequence, and you can probably see some math happening here in a second, what happens is if we draw in this right here, so another radius, we get a right triangle. And that means what? Well, if we know certain information, things like the Pythagorean theorem, remember that? Legs squared plus leg squared equals hypotenuse squared. When we get to some examples, you'll see what I'm talking about in terms of how to actually use that. But this concludes page 1. We've now covered circle, radius, chord, diameter, the relationship between a chord and a radius, and it probably should be stated when the radius is perpendicular to the chord, as well as, hopefully a blast from the past that you recognize, the Pythagorean theorem. So that's all for page 1.